Hello again, everybody. Today I'm going to cover the last couple sections of Chapter 4, and then we're going to do a quick intro to Chapter 5. So I promise you this lesson won't be as long as the last one. So today what I'm going to do is, first thing is I'm going to speak a little bit about how we can use the relational operators that we've seen previously, how we can use them with strings. And we saw how we can use the relational operators quite simply with the primitive types, right? If you want to compare um, two items that are like integers or floats or shorts or even characters. Okay, all those relational operators work fine with the primitive types, and you can also use those same operators with the string data type. And the string data type is technically what's referred to as a class type or an object type. And we can use the relational operators that we've seen, like less than, greater than, less than or equal to, greater than or equal to, so on and so forth with the with string types. So let me go ahead and show you guys some examples here real quick. The first thing I'm going to do is so if I want to work with strings, first thing I need to do is make sure that I include the string library. So I'm going to do a little pound include here, pound include string. All right, now I have access to the string library. And now what I'm going to do is I'm just going to declare two local strings here. I'm going to have one, I'll call it string, I don't know, I'm just going to call it S1 just to be brief. I'm going to say S1 is equal to Bob. Let me create another one, string S2, that's equal to Sue. All right. So there we have two strings. All right, now what we can do is we can use the relational operators to do comparison. So we can do a test to see is S1 equal to or equivalent to S2, is S1 less than S2, meaning does it come before S2 alphabetically or what they call lexicographically. So we can check for if two strings are not equal to one another. So we can do those types of things. So let's do a quick example here. So let's say I don't know. Let's say I want to do if, let's say S1 is less than S2, they're going to say cout S1 comes before S2. And else, oops, forgot my else. I'm going to copy this down. Else, I'm going to say S1 comes after S2. So what is this doing here? So on line number 10, what's happening is the less than sign, which is the less than relational operator, is going to be used to test is S1 less than or S2. That is essentially saying, hey, is string 1, does it come before S2 alphabetically? That's what it's doing there. And we could do the same thing with the greater than symbol or less than or equal to or greater than or equal to. So here I'm not actually testing for any equality. I just want to see if it comes before or after S2. So if I run this now, you'll see that we should find out that, Bob does come before Sue. So if I run this, right, it should say Bob comes before Sue. Let's make this correct. Comes before Sue. Otherwise, it would come after Sue. So that's how we can use relational operators with strings. We can also use the relational operators to test if strings are equivalent to one another. So if I wanted to, I could say, is S1, let's say if I want to just do a test here, and imagine your strings are being fed into your system from either the keyboard, maybe you're reading in a file, the data is coming from a database, or whatever it is, but it's probably not going to be something that's hard-coded. But we can use strings, and now they're populated as a separate issue. So let's say I want to see if S1 is equal to, let's say, I don't know, Bob. So here I can do a test, all right, and I can use the double equal sign, which is the equality operator, to see if in fact string 1 is equal to, in this case here, a literal, which is just Bob. I could also compare it to S2 if I wanted to. It doesn't matter. You're just doing some kind of string comparison. So here, if this is true, I'm going to say that, S1 equals Bob. Keep this simple here. else S1, keep forgetting my S's here, S1 equals Bob, otherwise I'm saying S1 is, I'm just going to say not equals Bob. All right. So in this case here, what should we expect? Since S1 is in fact equal to capital B, lowercase ob, all right, we should expect the first statement, which is on line 11, to execute. So if we do this, all right, so Bob equals Bob. Perfect, that's what you expect. What if I change this to be, I don't know, let's do all uppercase BOB. Then they're not going to be equivalent because again, since C++ is a case-sensitive language, lower capital B, lowercase ob is not the same thing as all uppercase BOB. So here I'd expect that statement line number 13 should execute and say that that string 1 does not equal Bob, right? So Bob not equals capital B ob, and I should probably change this, right, just to be consistent, right? Change this to this. And you get the same result, but the format will be better. I just want to say, right. So you can say Bob not equals all uppercase Bob. So that's how you can use relational operators with strings. Super useful if you're familiar with any other languages, like for example Java. This works a bit different. Okay, so if you took the Intro to Computer Science class using Java, you'll see that string comparison is a little bit different than in C++, but nonetheless the logic is the same. The next thing I want to talk about is another operator, which is called the conditional operator. The conditional operator is the one operator, and I believe it's the only operator, which is what's called a ternary operator, meaning that it actually takes 3 operands. Now, I'm not aware if there's any others, but it's possible. But nonetheless, this is the one ternary operator that you're going to see, which just means that it's an operator that takes not 2 but 3 operands. And the idea is that one of the things that we do in programming, which is so common, is to create small switch statements where we're saying, if this, do that, else do something else, and you're constantly doing this in your programs. So a lot of the languages, including C++, have come up with a sort of a shortcut for a if-else statement for cases where we have just like some small branching that we need to do. And the syntax looks like this. All right. So here we have an expression. Okay. The expression on the left side of the question mark here is something that's going to evaluate to either true or false. And depending upon what the evaluation of this first expression, one of these 2 things will be returned from the entire operation. So if this expression is true, what's going to be returned is the value that's after the question mark. If this value is false, what's going to be returned is the value after the colon. And here's a little example that we'll see in a book, and we'll try one ourselves in a second here. So in this statement here, it does a little test and says, okay, x less than 0. So if in fact x is less than 0, what they're going to do is we're going to assign 10 to y. Else, they're going to assign 20 to z. And that's how the logic works here. So it's a very useful operator. Let's try one on our own. So let me toggle back to my IDE. And since we started working with strings today, let's kind of continue with that theme for right now. So what I want to do is I'm going to create a little, I'm going to use a conditional operator to do like a little comparison as to whether or not somebody like passed a test or what have you. All right. So again, there's 2 outcomes: either you pass or you don't pass. And this is a common thing in programming where you have 1 of 2 conditions or 2 branches that you're going to take. So here what I'm going to do is I'm going to create string result. And this is just going to store, you pass or you fail, that kind of a thing, depending upon what the value is of your test, your score. Then I create another local variable here. I'm going to call it score. And I'm going to say that's equal to 80. I'm going to hard code some values in here just to make this brief. Now what I'm going to do is I'm going to say, okay, result, my string is going to equal to the conditional operation that I'm going to show you now. So here, if my score let's say is greater than or equal to 70, this is probably a good place to I'm sorry, not to hard code the value 70, but to use a constant, but I'm just trying to keep this simple for now. So if the score is greater than or equal to 70, then, okay, the result of this expression is going to be equal to you pass. Else, the result of this expression is going to be you fail. All right, that's it. Before we go any further, let me mention that so this is a test that's going to be get done. You can think of this as the evaluation of a Boolean expression. Say, if score is greater than or equal to 70, right? So this is going to be something that evaluates it true or false. If this is true, which in this case here it is, what's going to return from this entire expression is the string you pass. So you pass will then be stored in a variable that's called result, which is my string variable. If this works out to be false, what's going to be returned is this string over here. This string over here, you fail, will be stored in the value. I'm sorry, the you fail will be stored in my local string variable, which is called result. So one of these two conditions is going to be returned from here. It's important to note, and I'll show you a typical compiler that you'll see in a minute. This data type over here, okay, needs to match this data type over here, because if this thing is going to return a string, what you're going to assign this to needs to be a string. If you're returning a string over here, what you're going to be assigning it to needs to be a string. And I'll show you what the compiler will look like in a minute if we do something like that. So let's just do a little cout here, result. Right, so I just want to display the result. Right. So in this case here, what do you think the result is going to be? Well, since the person's score, which again, imagine this is being fed in from another system or a file or what have you, since 80 is greater than or equal to 70, what's going to be returned over here is you pass. All right, so you pass will be assigned to my variable that's called result. There you go, you pass. Let me switch this around to say, okay, what if your score, let's imagine your score is only a 50. All right. If I run this now, well, this expression here is going to evaluate to be false, right? Since score is 50, right? 50 is not greater than or equal to 70. So since this is false, what's going to be returned is this string over here is going to be assigned to result. So if I run this, it says that you fail. Simple as that. So anyway, super useful. I would definitely get comfortable using this for small if-else statements that you need to use. And again, let me show you a typical error that you might come across. So let's imagine I have a variable that's called bool, right? So let's say a bool result, and the result you think is going to be either true for you pass or false if you fail, something like that. If I compile this, I would imagine I'm going to get some kind of compiler error. Actually, I get a warning. This is a warning that you wouldn't want to ignore. So we're forcing true. Okay. All right. So what happens here is we're going to store. Actually, we haven't covered what are called character pointers, and actually don't cover that in this class. That's in the next course. So what we're trying to do is you can't take this thing here, which is a constant character string, and store it in a variable that's of type bool. So that's why you're getting the warning here. This is a warning that we probably wouldn't want to ignore. We'd want to fix this. I'm actually kind of surprised my compiler doesn't treat this as an error, but nonetheless. But let's see what happens. So score is 50, and what do I get back? I get back some strange result. So is 50 greater than or equal to 70? No, that's false. So what I would expect to get back is like 0 or something. This is actually returning a 1, okay, which typically 1 refers is the value for true. Let me change my variable back here to be what I had before, 80. Let me put that back to 80. Still get the same warning, and let's see what we get back here, and we get a 1 again. So this would be a really elusive bug to find in your program if you were to have something like this. So I don't like the warning that we're getting. I would hope or expect that to be an error, because in both conditions here, when I ran this, the value that was stored in result was equal to a 1. And remember, in C++, anything other than 0, for example 1, is considered to be true. So when I ran this program with both scores, it essentially worked to be true in both conditions, which is not what we want. And that would be a really, really difficult bug to find later on in your program. But the next thing I want to cover is the concept of what's called variable scope. And the way that variable scope works within C++ is that each variable is visible within a particular part of your program, okay, which is where the variable can be used. Meaning that you can have a variable with the same name as long as it's visible in a different part of your program. And this is a common thing, okay, because you have a large complex system, and imagine like a system at the college where you're keeping track of student grades or something like that. Well, multiple parts of the larger program or system may use a variable that's called like student, okay, because student is just one of the nouns that's part of the system. So we want to be able to use that variable name in different parts of our program, but we need to make sure that we are using a variable within the proper scope. So let's take a look at a real simple example. We're going to talk more about variable scope later when we cover. I believe it's probably like chapter 6 when we cover the notion of functions, all right, and that's when variable scope becomes really important. So, as I said, variables have their own scope based upon the part of the program where they're visible. So here I have a program that's called main, right? I have a function that's called main, and I have a pair of curly braces, and I'm free to do something like this. And let's use the variable score again, and we'll assign this to a value 80. This is telling me that within the function main right here, there's a local variable that's called score, and it's assigned the value 80. What I can also do is within this little function here, I can create another block statement. Remember, a block statement is just a pair of curly braces, and within that block statement, you can also create local variables. And you'll then, if you have a variable with the same name, you're going to do what's called shadow the variable that's on the outside of the block statement. I think it's easier for me to show you than it is to explain. So in order to create a really simple block statement here, let me just create a little if statement that just says if true. What does if true mean? All right, this just means that whatever is between these pair of curly braces will always execute, and that's what I'm trying to do in this example here. So what I can do now is I can create another variable with the same name. I'm going to call it score, and I'm going to assign it a value, what I used before, 50. All right. Your compiler is not going to complain here because the variable that's called score on line 10 is shadowing the variable that's called score on line 7. So what happens is within my block code, my block statement here, within this bit of code here, if I refer to a variable that's called score, refer to it meaning that I want to do some relational operations on there, I want to use score for some calculations or just to display it to the console, whatever it is. Anytime I refer to the variable score, okay, within the curly braces, it's going to be referring to the score that's on line 10, not the one that's on line 7, because the one on line 7 is out of scope. So if I just did something like this, let's say score in block equals score. Okay. So on line 11, I'm just going to use the variable score to display something to the console. The variable score that's going to be referring to is the one on line 10. Here I'm going to do another caret again, all right, and I'm going to say score in, okay, let's call it outside of block equals score. Now if I build this, my compiler is not going to complain. All right. Normally you would think, okay, I can't have two variables with the same name. However, since they're both in a different level of scope, you're allowed to do this. Okay. So on line 11, what's going to display is going to say score in block is equal to, in this case here, we assign the value 50. On line 14, when I say score outside of block, okay, the variable score is now referring to the one on line 7, which is where I assigned the value 80. So if I run this thing, you'll see the difference in behavior, right? So the score in a block is equal to 50, and the score outside of the block is equal to 80. All right. So that means if I were to do something like this, and I said score, plus equals 10 or something. All right. So here I'm just incrementing score by 10. Which score am I going to be using? I'm going to be using a score that was defined on line number 7. Actually, you see within my IDE, it actually even highlights. Right? If I select this variable here, score, it actually tells me which one it's using within that particular scope. So if I build this now, just get the same result that we said score in the block, but the score outside of the block should now be equal to 90. So that's the basics of variable scope. I just want to, this is the last part of chapter 4, and I just wanted to kind of introduce this to you guys because it's important that you understand how variable scope works, because you could come across some like rather unusual bugs in your program if you unintentionally do something like this. Again, you might intentionally want to do something like this, but if you unintentionally did something like that, you just need to be aware of the fact that which variable is going to be used. But like I said before, variable scope becomes more important later on when we start talking about functions and how we create functions and pass values to functions and all that good stuff. So, all right, so that's it for chapter 4. Let's take a look at some of the items that we're going to cover in chapter 5 now, at least just the beginning. Again, I promise you that this week we're going to go so far. So I think we're just going to cover probably the first 2, maybe 3 sections of chapter 5, and then we'll be in good shape. All right, here in chapter 5, we're for today we're just going to cover the first 2 sections of chapter 5. And actually, chapter 5 we're going to cover some good stuff, and we're going to kind of slow down a little bit. So the chapter 5 can be summarized in, we're going to learn about what a loop is and how to use the different types of loops to repeat parts of your program. And we're also going to just see like a quick intro into how we can read and write data from a file. All right, so it's just another place to get our input. So it's in chapter 5.1. I want to go through this in a book here real quick. I think just to have a good illustration here. And chapter 5, section 5.1 covers what's called increment and decrement operators. In programming, it's such a common task to always either add or remove one from a value because you're iterating over some data or what have you, that C++ and other languages like Java have a shortcut for doing such a thing. And we're going to learn about what's called a plus plus and minus minus operator, which is actually what's referred to as a unary operator because it only takes one operand. So the idea is that we've seen if you have a variable and you need to increase a variable by the value 1, well, we could do something like this. We could say, again, imagine num is equal to a integer or what have you. So we could say num is equal to itself plus 1, or just num is equal to num plus 1. We also learned about the shortcut. We can say num plus equals, right? This is a shortcut for what we have above, num plus equals 1. So that's another way how we can add a value of 1 to a variable. Likewise, we can also do the same thing if we want to decrement or reduce a value by 1, a variable by 1. So I could say num is equal to itself minus 1, or I can just say num minus equals 1. So both of these tasks, and probably more commonly the first one where we're doing addition, is so common that C++ has a shortcut where we can use what's called the increment and decrement operator, which is a pair of plus signs or a pair of minus signs. And this statement down here where we say num plus plus, okay, this statement by itself is equivalent to saying num is equal to num plus 1, as we saw above, or num plus equals 1. Meaning that these guys here are equivalent to this. Likewise, you can also do num minus minus. Where's your num minus minus? And then again, that's here it is. I'm sorry, num minus minus. So both of these will perform the same tasks. Either going to add one value to num, or it's going to reduce num by one value. And just be aware that these guys here are unary operators. So the plus plus only has one operand, which is num, and minus minus only has one operand, which is called num. So let's talk about let's do a little example here. I'm going to show you what's referred to. You might want to read through this in your book when you get a chance. You can use the plus plus or minus minus operator in what's called postfix mode or prefix mode. Basically what it means is that you can either put the plus plus sign before num or the minus minus sign, or you can put the plus plus sign after num or minus minus after num, and they're treated a little bit differently. All right, so let's take a look at that. So if the operator comes before the variable, that's called prefix mode. If the operator comes after the variable, such as we have up here, and it's called postfix mode. So let's take a look at a little example, and I think that'll help to illustrate that. So I'm going to create two variables here. I'm going to call it int postfix num, and I'm just going to assign it to the value 0, not portfix, postfix. And I'm going to create another variable here, which is going to be called. Let's do this as one statement at a time. I think that'd be better. All right, so let's imagine here I'm just going to display the contents of postfix num. Right? So postfix num. Let me put this in pair of parentheses. And we're going to do this two times. So we're going to display this the first time. We're just going to say postfix num. And what we're going to do is we're going to say postfix num plus plus. And then we're going to copy and paste this down over here. And I'm going to just display it again, postfix num. And actually I'm going to get rid of the plus plus here because we're going to use this variable once. So what's going to happen is on line 7, all right, we're going to display a little cout statement. We're going to display our little string postfix num, and then we're going to do postfix num plus plus. The plus plus in this case here is being used in what's called postfix mode, meaning that the variable is going to be used first and then it will be incremented. So what does that mean in this case here? The variable is going to be used, meaning it's going to be fed into my cout stream, and then it will be incremented. So what's going to display is going to say postfix num, and let's just put an equal sign in here or something. All right, postfix num is going to be equal to 0 on line 7. Then postfix num is going to be incremented, meaning 1 is going to be added to it. And then on line number 8, all right, where we have the second iteration of this, we're going to say postfix num is equal to, and the second time around, postfix num should be equal to the value 1. So let's run this and we'll see what happens. So again, so the first time around, postfix num is equal to 0. Second time around, postfix num is equal to 1. And again, that's being used in what's called postfix mode. Let's illustrate the same thing, but we're going to do it in prefix mode. So here I'm going to create another variable. I'm going to call it prefix num. And again, I'm going to assign that to the value 0, just as we saw before. And now what I'm going to do is say cout. And I'm going to do this twice, so let's do it this way. I'm going to say prefix num is equal to, I'm going to say plus plus. Right now, using the increment operator in prefix mode, so I'm going to say prefix num. All right. Let me copy and paste this line down here. So the second time around, let's just display what the variable looks like afterwards, so before and after. All right. Now here on the lines 11 and 12, there's a distinct difference between what we did previously on line 7 and 8. So on line 11, when we do a little cout, and we have the string literal, and then we have the plus plus prefix num. The prefix operator, okay, is going to cause our variable prefix num to be incremented by 1 first, and then the variable will be used, meaning that it will be inserted into the cout stream. Then on line number 12, where we do it again, we're just going to display the value of prefix num again, which you'll see what's going to be equivalent on lines 11 and 12. So again, the difference is with the prefix operator, the variable is incremented first and then it is used, which is the converse of what the postfix num is. So let's, just so we can have an additional line in here, let's just show you again how postfix and prefix is going to work here. So on the lines 11 and 12, when prefix num is displayed, it should display the value 1, and then on the second time around on line 12, it should also display the value 1 again. So that's how this works. All right, so just be aware of this. To be honest with you, the vast majority of times you're going to be using the postfix the increment operator in postfix mode. But there may be times where you want to use the increment operator in prefix mode. Again, that happens to be the same whether it's the increment, addition, or the decrement subtraction operator. So again, this is the most common way that you use this, but you may come across cases where we use it in prefix mode also. All right, the last thing that we're going to cover for today, and this is a really important topic, and it's the notion of what's called a loop. And this is something that all programming language, I don't want to say all, but any programming language I ever come across has. Now, what is a loop? As it specifies here in the book, right? It says just a loop is a part of a program that repeats. Again, a loop is a control structure which allows your program to repeat some statement, or typically statements, over and over a number of times until you tell the program not to do that anymore. Super useful, used for many different tasks, and we'll see like a quick intro today into some of the tasks that we could use it for. But there's the basic idea is that you want to be able to have some part of your program conditionally execute some number of times, and that number of times is something that you control as the programmer. And in C++, there's a variety of different loops, and most languages have the same thing too. Right? They'll have different types of loops based upon the how you want to handle the conditions. So in C++, along with Java, all right, there's 3 loops. The first one that we're going to see is what's called the while loop. Then there's another loop that's called a do while loop. And then the last one is what's called the for loop, which is probably the most common one. It's the one that you'll probably see most often in this course. And if you continue on, it's a control structure that's super common. So we're going to start off with the simple one today, which is what's called the while loop. And let's go through how the syntax is lined up. Well, actually, before we look at the syntax, let's take a look at this little diagram here on your book. In your book. And the idea, it works like this. So, this is kind of like the flow of your program. So your flow of your program comes down to here, and we come across some expression, right? So an expression is something that's going to be evaluated to either true, such as, if, grade is greater than 70, do something, all right? So this is something that's going to evaluate to either true or false. If it evaluates to true, we're going to execute some statement or perhaps statements. Okay, and then once this statement is done, we'll come back up over here. We'll go ahead and test this expression again. Is this still true? Okay, if it is, let's go back and execute some statement or statements. Come back up over here. Is this true? At some point in time, this expression is going to have to become false, and when it becomes false, we continue on with our program. So this is a nice little flow diagram, as they call it, which shows you how to use, or actually how any loop functions. Okay, whether it's a while loop or a do while loop, or actually, this is kind of specific to a while loop. A do while loop is slightly different, and we'll see that later. But a for loop is about the same. So this is a good example of a while loop. And let me go over the syntax, all right, or the format of the syntax. And it looks like this. So the setup is very similar to like an if statement. But now what we're going to use is we're going to use the while keyword. So we say while, and then here we have expression, right? So something that's wrapped in a pair of parentheses, So while this expression is true, execute this statement. Once this expression becomes false, don't execute this statement anymore and continue on with the program. This is how we would use a while loop in a part of a program where we only want to have one statement paired with our loop, such as what we had in our if statement. All right, so we don't have to use curly braces here, but if we don't, remember this statement is going to be paired with this while loop here. If we want to have multiple statements execute, what we would do is we would use this type of syntax where we use our curly braces again. And I would say while expression, right? So meaning while something is true, do everything that's within this pair of curly braces. So you could have multiple statements paired to one while loop. Eventually this expression is going to become false. Once it becomes false, don't execute this stuff any longer and continue on after the while loop. The author has some examples here. You could go through it. Actually, I think it's a pretty good simple example. Let's do it together on our own over here. So let me get rid of this stuff. And I'm just going to create a little while loop that is going. Actually, no, maybe I'll use the example that's similar to what the author has. So what I want to do is I'm going to create a while loop that's going to display the value of a variable, and also the word hello or something like that some number of times. So let me create a little local variable, and this is going to be my counter variable. Let's say count is equal to 1. And here I'm going to begin my while loop. I'm going to say while. Again, you notice that, at least in my ID, this shows up as blue. Since this is appearing in blue, you know it's a keyword, meaning you can't use it for anything else because it's already reserved or a keyword. All right, so what I'm going to do is I need to create an expression here, something that's going to evaluate to either true or false. And here I'm going to say while count is less than or equal to 5. All right. I want to do something, and here I'm just going to display hello, and then the value of my counter variable. Hello, oh, I used a plus sign, wrong language. All right, so in this case here, what's going to happen is on line 8, we come across to a while loop, and here's our expression. And our expression is going to say, okay, while count is less than or equal to 5, display this statement. All right, so I'm just going to say hello, and actually I need to increment the value of count. And this should display 5 times. Right? So if I build this thing, actually, you know what? Let's do this just so you can see when it ends. Here, after my while statement, my while loop, at the very end, I'm just going to say the end of program. Okay. So line number 9 is going to execute 5 times. Okay. Line number 11 is going to execute just once, because at some point in time this expression is going to become false, right? Because if we keep incrementing, if we can keep incrementing the value of count, right, starting at 1, then it's going to go to 2, then 3, then 4, then 5. Eventually it's going to hit 6. Once count becomes 6, well, this then, right, count, right, less than or equal to 5, right, 6 less than or equal to 5, that will become false. Once this becomes false, this statement will no longer execute, right? Execution then goes to the statement following your while loop, and in this case here it's the end of my program, which is just line number 11, and we'll say that it's the end of my program. So if I run this thing, right, it will display hello 5 times, right? 1, 2, 3, 4, 5. Then I execute the statement which just says the end of program. Right? Let me go back to the book here real quick and let me show you something. And it's got to be in there somewhere. All right. Okay, so here it says, here's how the loop works, right? The expression is tested, and if it is true, this statement is executed. Then the expression is tested again. If it is true, the statement is executed. This cycle repeats until the expression is false. All right. So what happens here is I need to make sure that whatever I put within my while expression here, at some point in time, it has to, at some point in time, this has to evaluate to false. If it doesn't, meaning that if it always remains true, I'm going to create what's called an infinite loop, meaning that that bit of my program is going to execute indefinitely until I terminate the program, my laptop runs out of battery or whatever it is, but it'll be what's called an infinite loop. And let me show you an example as to how we can create an infinite loop. And let me show you a common error that students make. So again, here in this example, I don't have a block statement. I just have the statement that's on line 9 paired with my while loop on line 8. What's happening now is since I got rid of the increment operator after the count, this loop, okay, will execute indefinitely, because since I'm never changing the value of count, this guy over here, count, will always be less than or equal to 5 because I'm initializing it to 1. This is always going to be equal to true. If I run my program right now, you're going to see that it's just going to display hello. It's going to keep repeating and repeating it over and over and over again, displaying the value 1. If you ever get into this condition, if you're running in debug, or actually with if you're running it not in debug mode, if you just hit Control F5, Control C. If you hit Control C on your keyboard, that will terminate the process, and you can then get back to your program over here. All right. So what I could do is, since I created an infinite loop, well, I need to now go into my program and do something that's going to cause my while loop to eventually evaluate to false. And here I could do, say, count, not cout, count. Right. Count plus plus, excuse me, count plus plus. And here, all right, what I'm doing is I have a programming error here, but you might think that what's going to happen here on line 10 is that, okay, well, on line 10 I'm going to increment the value of count from 1 to 2 to 2 to 3 to 3 to 4 to 4 to 5, and then eventually 5 to 6. And once I do that, the expression on line number 8 within a pair of parentheses will eventually evaluate to be false. In this case here, that won't occur because since I don't have a block statement here, right? I don't have a pair of curly braces. The only line of code, or the only statement that is paired with my while loop, is the bit of code that's on line number 9. So line number 10 will actually never be, execution will never actually get to line number 10 because I'm going to be in infinite loop again. So if I run my program again, let me show you what happens here. So if I do this, right, it's still saying hello 1. All right. Again, the reason is because I'm never getting to the statement that has the increment operator on there. So let me do Control C here. Again, let's get out of this. What I should do is, right, I want to put this into a pair of parentheses, right? So this is now the end of my while loop. And this is typically how you'll create loops in your program, and it's very similar to how you created if and if else statements within the relational operators that we saw before. Is that you're going to probably have more than one line of code and more than one statement that's paired with a while loop. So here, once execution hits line number 8, we check is count less than or equal to 5. Yes, it is, right? Because count is equal to 1. Since that's true, we're going to jump down to execution. We're going to execute line number 9 to display hello and then the value of count. And then we're going to jump down to line number 10. Here we just increment the value of count by 1. So count now is going to become equal to 2. Execution comes down to here, which is the end of my while loop. We come back up to here. We do the test. Remember, count is now equal to 2. Is 2 less than or equal to 5? Yes, it is. Since it is, we jump down to here, we execute line number 9, which is just going to display hello and the value of count, which is 2. Then we come down to here on line number 10, and we increment the value of count by 1, so 2 now becomes 3. Execution then jumps down to here to the end of my while loop. We come back up to here, count is now equal to 3. We do our little test. Is 3 less than or equal to 5? Yes, it is. So we go through the whole process again. And as we continue to do that, eventually we're going to change the value of count to a value which is going to cause a statement on line number 8 within the parentheses to evaluate the faults. Once that evaluates the faults, terminate execution of the code within my while loop will terminate, and whatever the next statement is after my while loop, which is line number 12 in this case here, will be the bit of code that executes. So let me run this. So now we get back to the same result that we saw before. All right. Now that we know a little bit about block statements, I suggest that you get more comfortable with using the parentheses when you create block statements. The reason is because, first of all, I think it's a little bit easier on your eyes to see what bit of code is paired with the while loop in this case here. And in addition to that, sometimes what happens is either you or somebody else goes into your program and it makes some changes to the code, which is perhaps part of a while loop or an if statement, what have you. And if it's not within a pair of parentheses, it's real easy to make a mistake and do something unintended where you think you're pairing some code with a while loop, but it turns out that you don't. So anyway, you can use whatever methodology you prefer, but I would suggest that you probably get in the habit of using block statements with the curly braces, and I think you'll be less prone to make errors down the road. So anyway, again, I promised I would make it a little bit shorter today, so that's going to wrap up this section of this lesson. So we covered the while loop. Next week when we come back, we'll cover what's called the do while loop and the for loop, and then we'll see how they differ and see why you use one over the other, and each one of them has a sort of a general purpose, and if you know what the purpose is of what you're trying to do behind the scenes in your program, you typically want to use the appropriate loop. So anyway, that's it for this week. Bye bye.